Hi! Today we will present about the three chemical bonding types. So first we are going to start with the covalent bond.
A covalent bonding is when a pair of electrons or more are shared by two elements. According to the octet rule, elements or atoms need to have a full outer shell in order to become stable. Some elements share, lose, or gain electrons, but in the case of a covalent bond, they share electrons. Covalent bonds usually form between nonmetals. There can be many bonds between two elements. One bond consists of two electrons, therefore two bonds contain 4 electrons shared, and so on. In this video, I am showing you a single bond, which is not as strong as a double or triple bond, but is the most stable. I have a model here of a structure of hydrogen fluoride, which consists of one hydrogen atom and one fluorine atom. Hydrogen has 1 electron, and so it has only 1 electron on just one shell. The first shell can contain 2 electrons, so it needs 1 more electron in order to have a full shell. Fluorine here has 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Since it has 9 electrons, its electron configuration is 2 and 7. Since the second shell can contain 8 electrons, fluorine needs 1 more electron in order to have a full outer shell and become stable. Because both hydrogen and fluorine needs 1 more electron each, they can share their electrons. Hydrogen can share its electron with fluorine, and fluorine can share one of its electrons with hydrogen. This action creates a single covalent bond, allowing both the elements to become stable. So the covalent bond is this creates a covalent bond which has 2 electrons in a single bond. The characteristics of a covalent compound are that they are either a liquid or gas, they are slightly polar or attractive, and they also have a low melting and boiling point.
Ionic bond is a complete transfer of valence electron between two elements, which are metal and non-metal. It is one type of chemical bond produced between two oppositely charged ions. Every element wants a full outer shell like a noble gas configuration. This is why they lose and gain electrons from other elements. Here is an example of an ionic bond shown in our model here. This model is a sodium chloride. It is a substance of the result of both chlorine and sodium. Sodium has 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And its electron configuration is 2 here, 8, and only 1 here. The first inner shell is full since it can only contain 2 electrons here. The second shell is also full because it can contain with 8 electrons. This is the second shell. But you can see that the third shell has only 1 electron. Therefore, it is not full since it should have 8 electrons. Fortunately, chlorine also wants more electrons to have a full outer shell. This is because chlorine has only 17 electrons. Here, 2 and 8 and 7, they want more. It is easiest for sodium to get rid of 1 electron and for chlorine to gain 1 more electron. With this say, sodium could easily give 1 electron to chlorine. The characteristics of an ionic bond are that they can attract the electrons of the other atom. They are solid in standard pressure and temperature, and they also have a high melting and boiling point. They can conduct electricity because of the strong attractive force between oppositely charged ions. This is a physical example of one of the type of bonds. This is sodium chloride or salt, which is ionic bond. This is a salt. Metallic bonds are found only between metals. There are no non-metal or metalloids involved. In this case, aluminium is a metal. The characteristics of metallic bonds are they have a high melting and boiling point. They are strong and hard to break. They conduct electricity well because the electrons are free moving, so they carry the charge that they have from place to place. Lastly, they are ductile, which means that they are flexible and can be rolled out into a wire. Let's look at what actually forms a bond. In this model, we are using aluminum atoms. Aluminum has an electron configuration of 2, 8 here, and 3 in the third valence. So it needs to get rid of 3 electrons to form a full outer shell.
This is why some electrons are separated from the parent atoms as shown. Since electrons are negative, when they meet other electrons, which both of them are negative, they are repulsive from each other, so they pull back away from each other. However, the electrons are attracted to the nucleus of the other metal atoms, which are positive. Negative and positive attract, so the electrons are attracted to the nucleus like this. Because of this, when there is a group of the atoms of a metal staying together, the electrons get attracted to the atoms. Therefore, they are held together but not separated from each other. This creates the electron sea, and it is also why metallic bonds are strong.